It can be hard to understand what the term data science means. So I'm going to show you a little bit of analogy. And this is a construction analogy where our goal is to build a beautiful house. And what are we going to build it with? Well, we're going to build it with data. Doesn't look like much, a little bit intimidating, but there's a lot of it. And so what would we do? Well, let's look at the area, the plot, the width, the standard deviation. How spread out is it? How much room do we have to work with the data or to have an error? We could also talk about R squared, which would be kind of like looking at the neighborhood. What houses are similar? How similar do houses need to be in order to build in this area? Now, just because your neighbors have a house like this does not mean that you should build a house like that. In a similar way, we're going to talk about how R squared does not tell you that you have the right model for the data, but it's helpful information that a client might want to know. To find out if you do have the right model, you check the blueprints, which is the residuals. They will tell you whether you have correctly modeled what is found in that data and whether you can get the accurate predictions or the house plan that you're after. And so you can build some pretty basic, simple types of houses, and that's probably where you got to in the intro course, and you should be proud of that. But here in methods, we're going to go a little further. Thanks to R code, we can connect things in stronger, different ways. And one of the tools is the t-test, which has a p-value and a confidence interval. Those are two different sides of the same tool and very versatile. One thing to be aware of is once you learn how to use a tool, if you know how to use a hammer, everything looks like a nail. And you might think those simple tests from the introductory course will give you everything you need. Well, not necessarily. So let's talk about doing some more complicated patterns. That's LM for linear model, and we will talk about how to do this R code so that we can build more complicated structures, more impressive things. Categorical effects is another tool that you sometimes use if you have categorical effects. That doesn't mean you need it always. When you do need it, you can start to build more beautiful, amazing things. And interactions gives you more versatility for how do these categorical effects cause curvature in the data and how do we model that so that we can get closer to our beautiful mansion that we're trying to build. And we'll learn some numerical interactions which should be added to your toolkit to get even more impressive buildings. And when we talk about which variables should we be using or which variables to take out, that can be like constructing a team. Do we want these 5 together or just that one person alone? And also, we'll pick up some log transformations. Those are more tools that can go into your toolkit so that you can build even more impressive homes. But don't get the impression that the computer science and the statistics are the only pieces you need. We also need to talk about how do you write an introduction, plots, conclusions. Those make it beautiful and more enjoyable for other people to see what you're doing so that they will want to live in their beautiful home. And as a data scientist, what you're delivering is a beautiful report that anyone can read, even if they're not a computer scientist, not a statistician, not a mathematician. They can understand what's in the data and use the data to make conclusions.